In 1981, the newly opened Hyatt Regency in Kansas City was a striking architectural achievement. Its defining feature was a series of floating skywalks suspended cleanly across a massive open atrium. On the evening of July 17th, the space was packed with over 1,500 people gathered in the lobby and up on those suspended walkways for a Friday night tea dance. Then, at exactly 7:05 p.m., a loud popping noise echoed through the room. The fourth-floor walkway snapped, and the entire structure along with the second-floor walkway tethered beneath it crashed directly down into the crowded dance floor. 114 people were killed, and over 200 were injured, making it the deadliest structural disaster in U.S. history at the time. There was no earthquake, no bomb, and no extreme weather event. A brand-new, state-of-the-art building simply fell out of the sky. Figuring out why meant looking closely at the steel itself. Investigators arrived to a labyrinth of twisted metal and crushed concrete, looking for a single mechanical failure point somewhere in the wreckage of the massive walkways that now rested dead on the lobby floor. Out of all the debris, forensic engineers zeroed in on one specific repeating element, the steel box beams that were supposed to hold the walkways up in the air. When investigators examined the fourth-floor wreckage, they saw the box beams at the hanger rod connections had been severely warped and deformed. The heavy steel retaining nuts that held the rods in place didn't snap off. Instead, the intense downward weight caused the nuts to rip straight upward through the welded seams of the box beams, tearing the steel apart like an aluminum can. The load on the metal connection exceeded its capacity. To find out how it was built this way, the investigation moved from the rubble to the engineering blueprints. The original design called for a single continuous 45-foot steel rod to drop from the ceiling, meaning each walkway would independently transfer its own weight directly up to the roof. But implementing this on a real construction site presented a major hurdle. Threading a continuous 45-foot steel rod on the job was incredibly difficult, and contractors ran the risk of stripping the threads entirely during installation. To simplify assembly, fabricators proposed an as-built revision. Instead of one continuous rod, they used two offset tie rods. This design change redirected the load path. The second-floor walkway no longer hung from the ceiling. It hung directly from the fourth-floor box beam. While this single tweak was made to simplify construction, it shifted how every pound of weight was distributed through the building's frame. To understand the mathematical reality of what happened, we can use a simple analogy. The original design is like two people holding a rope independently, where the rope holds their combined weight, but each person's hands only support their individual body weight. The altered two-rod design changes the equation. Now, the top person holds the rope while the second person hangs entirely onto their ankles. Up on the fourth floor, that single box beam was now acting as the top person's grip. It was forced to support its own weight, plus the entire suspended weight of the second floor below it. The original box beam design was already engineered well below Kansas City's building codes. Doubling the load on a connection that was already insufficient meant the structure was doomed. On July 17th, the added weight of 1,500 dancing partygoers was the final stressor. The overloaded steel channel welds holding up the walkways were pushed past their physical breaking point, and they finally gave way. The collapse became a mathematical certainty the exact moment the two-rod system was installed, proving that an intuitive construction shortcut can easily conceal a catastrophic miscalculation. The investigation shifted from physical math to the procedural paper trail to find out how a doomed design legally made it into a finished building. It came down to a fatal miscommunication between contractors. The steel fabricator sketched the two-rod change, operating under the assumption that the structural engineers would verify the new load capacities. The lead engineering firm stamped and approved the revised shop drawings without performing a single basic calculation on the new connection, a check that would have instantly exposed the doubled load. This deadliest structural collapse in U.S. history at the time did not stem from a lack of advanced engineering knowledge. It happened because of a simple administrative failure to verify a seemingly harmless revision. The professional fallout was severe. The Missouri Licensing Board charged the lead engineering firm with gross negligence, incompetence, and misconduct, stripping the lead engineers of their licenses. Ultimately, over $140 million was paid out to the victims' families. Between society and engineers, there is an implicit handshake, an invisible binding trust that the built environment around us is mathematically safe to inhabit. Following the collapse, the engineering industry changed its standards. Suspended skywalks were virtually eliminated from commercial designs, and new requirements for mandatory math reviews were enforced for all non-redundant connections. The tragedy at the Hyatt Regency remains a permanent reminder that reality never forgives a procedural oversight. When human lives are in the balance, there is no such thing as a minor detail. End of report.